All right, this is Mr. Barr, and this is adding, subtracting, multiplying, and dividing complex numbers. It's really just a combination of all the last of the last 4 IXLs that you've done, I think. All right, so we're going to simplify this. In this case, the variable, the I just basically acts like a variable. So this is 10i minus 9i. That's just be 1i, right? 10 minus 1. So 7i. Negative 2 minus 6 is negative 4i. Multiplying it. So in this case, we know that an I times an I becomes a negative 1. Learned that earlier. So this is going to become 4. I times I, or I squared, is a negative 1, so it's going to be a negative 4. In this case, you learned that you cannot have an I in the denominator. So in order to handle this, I'm going to multiply it by I over I. That's going to give me 1i on top. 4 times I squared. I squared is negative 1, so it's 4 times negative 1, which is negative 4. So I over negative 4, or even better would be negative I over 4. A little distribution here. So negative 6i, and this is going to be 7i, which is 7i squared, which is 7 times negative 1, which is negative 7. Little distribution. So negative 5 times 5 is negative 25i. Negative 5 times 8 is negative 40. I times I is negative 1. So that negative 40 times negative 1 will become a positive 40. So negative 25i plus 40. I cannot have an I in the denominator, so I'll multiply by I over I. That's going to give me, see, oh, you know what? This one's easier than that. These just cancel out, don't they? So it's negative 4 over negative 3, which would be 4/3. Okay, we're going to go into a box for this one. Negative 5, negative 4i, negative 2, 5i. Negative 2 times negative 5 is 10. Negative 2 times negative 4 is 8i. Negative 5 times 5 is negative 25i. Negative 4 times 5 is negative 20. And I times I is negative 1. So this is 10 plus 20, right? Negative 20 plus negative 1 is a positive 20. 10 plus 20 is 30. And this is 8i minus 25i, which is negative 17i. Same idea right here. Go with the box method. Five, 5i, negative 4, negative 4i, negative 20, negative 20i, negative 20i. Negative 4 times 5 is negative 20. I times I is negative 1, so negative 20 times negative 1 is a positive 20. Interesting, in this case these cancel out, and I'm left with negative 40i. Right, I can't have an I in the denominator, so I'm going to multiply by I over I. That's going to give me 3I plus 5 times I squared, which is 5 times negative 1, which is negative 5. And it's going to be negative 2 times I squared, which is negative 2 times negative 1, which is a positive 2. And IXL is going to want it like this, negative 5 halves plus 3I over 2. Negative 5 halves plus 3I over 2. This is the same type of problem. I'm going to jump a level, and I think conjugates are going to start showing up in a moment. Yep, good. That was a good jump. You learned in an earlier one that I can't have an I in the denominator, and in this case, I have to multiply it by its conjugate, which is 2 minus 5I over 2 minus 5I. So on top, I'm going to have 2 minus 5I. And on the bottom, I have 2 times 2, which is 4. The middle terms are going to cancel out. And then I'm left with negative 25 times I squared, or negative 25 times negative I, which is a positive 25. So 2 minus 5I over 29. IXL is going to want me to split it up. You know, this is adding and subtracting with a little distribution. So this negative is going to distribute, make that a positive, and make this a negative. So I just distributed that. So I have 7.5I minus 4.6I. So 7.5 minus 4.6, 7.5 minus 4.6, that takes me to 2.9. And then I have negative 4.8 and positive 9.6. So 9.6 minus 4.8 is 4.8. And IXL wants it like this, 4.8 plus 2.9i. More of the same with no distribution though. So this is 0.3 minus 6.5, 0.3 minus 6.5, so negative 6.2, and 0.4 and 0.4 plus 1.7, which is going to take you to 2.1. There's nothing. This is an 83. This is nothing weird. What's that? Negative 9i. Right? Negative 0.4, negative 8.6. That takes me to a negative 9. Okay, I'm going to jump a level. Too weird. Let's see. So this is really I plus 1/2 plus 4/5 plus 9i over 5. That's an I. Common denominator of 5 here, so 5 over 5. Common denominator here, let's take it both up to tens. So 5i over 5 plus 9i over 5 equals 14i over 5, and I'm doing 1/2 plus 4/5. Common denominator of 10, so it's 5/10 plus 8 tenths, which takes me to 13 tenths. So those are the two components. So 13 tenths. 13 tenths plus 14i over 5. Okay, and good. I'm glad I got to this problem. All right. I can't have I in the denominator, so I need to multiply by the conjugate, which is 3 plus I. 3 plus I. Now the bottom's pretty easy because it's going to be 9 minus I squared, which is 9 minus negative 1, which is 9 plus 1. So the denominator is 10. And you could see that with the box method, right? Nine, 3i, negative 3i, negative I squared, which is negative negative 1, which is a positive 1. So it's 9 plus 1, and there's my 10. I have to also do a box for the top piece of this. 3 plus 2i. 3 plus I, that's the conjugate. So 9, 6i, 3i, 2i squared, which is negative 2. That's going to take me to 7 plus 9i. So it's going to be 7 tenths plus 9i over 10. 7 tenths plus 9i over 10. Good work. And this is a similar type of problem. Thanks for watching.